Welcome to Smart Passing Package for the subject Digital Signal Processing. Here I am going to discuss the important like a short notes and the concept oriented segment from module number 3. Module number 3 comprises of two segments. One is DFT properties. Another topic is efficient computing of DFT FFT algorithms. These are the two important topics which you can expect from module number 3. So the first topic is DFT properties. Coming to second topic, that is linear filtering using DFT. So we are mainly focusing on overlap add and overlap save method. Third topic is a Radix-2 FFT algorithm. So these are the three important topics which are comes under module number 3. So kindly follow these topics which will be really helpful for your exam point of view. So moving on to the discussion. So you should study about the time reversal of a sequence. What do you mean by time reversal of a sequence? So you can say like the x of n that is going to convert into capital X of k by using the DFT property. So then we can write like x of minus n mod n that is equal to x of minus k mod n by using the DFT. So the meaning is reverse time index that is equal to reverse frequency index. Here, the time domain is going to convert into frequency domain, correct? No? So here, reverse time index equal to reverse frequency index. That is the major property called time reversal. So kindly do understand this property. Circular frequency shift. What is another property of DFT? That is circular frequency shift. We have y of n is equal to x of n into wn wn raised to minus k into n. Therefore, y of k can be written as x of k minus k naught minus n. So this property is known as circular frequency shift property. So frequency shift is converted into the time multiplication. That is actually the main content. This is actually the theory portion. You may get a question like explain the DFT property, complex conjugate property. Suppose x of n is a real, then x of n minus k is equal to x conjugate of k. This used to reduce the computation. That is a plus point. Then multiplication of two sequence. So that is most important. So the time domain circular convolution is equal to frequency domain multiplication. So convolution will be represented by using the star with a circle. So x1 of n convolution x2 of n, that is nothing but x1 of k into x2 of k. Here it is in the frequency domain, where in the left side that is time domain. Convolution the time domain circular convolution will be directly equal to frequency domain multiplication. That point is very, very important. I request you to make a note of this. Similarly, another important theorem, that is Parseval's theorem. State and explain Parseval's theorem, one of the important questions. The theorem says that total energy in the time domain will be equal to total energy in the frequency domain. That's a statement you are supposed to write as soon as they ask the question like state and explain Parseval's theorem. Total energy which is available in the time domain will be 100% is equal to total energy in the frequency domain. Anyway, you are studying the law of energy conservation rule that is applicable here also. So basically, we can write like the energy signal in the time domain can be expressed as sigma n is equal to 0 to n minus 1 modulus of x of n the whole square. So if you express the same thing in the frequency domain, that is equal to 1 by n into sigma k is equal to 0 to n minus 1 modulus of x of either x of x of k the whole square. However, we can say that energy in the time domain will be equal to energy in the frequency domain. So this statement can be used for validating Parseval's theorem. So it is one of the most commonly asked question in the university examination. I have referred the various question paper and came to know that Parseval's theorem is very, very important. So other one is what do you mean by linear filtering using DFT? How will you perform linear filtering using DFT? So it is used for the lengthier sequences. For example, there are two methods of linear filtering using DFT. First method is called overlap add method. Other one is called overlap save method. So here the procedures of overlap add methods are input broken into certain blocks. So each block is actually performing the convolution. Then output is added with the overlap. This is called the overlap add method, which is very, very important. If I talk about overlap save method, so your first job is to input the block overlap. Second step is circular convolution will be performed. Third one is Third one is only valid fact is maintained. That is called overlap same method. Please do understand about these two methods because there are so many questions you can expect from overlap add method and same method, which is a part of linear filtering using DFT. So next is called very important Radix-2 FFT algorithm. State and explain Radix-2 FFT algorithm. Write the steps, or you may get a problems also. Direct DFT that is equal to O of n square, where FFT is equal to O of n log n base 2. There are two type of DFT algorithm. First one is called a DAT, okay, decimation in time. Split x of n into even and odd samples. That is called a decimation in time. DAF, decimation in frequency, split x of k into even and odd samples. That point you have to remember. Okay. So because in the gate examination and all, you may get a similar kind of questions. So in this regard, like Radix-2 FFT algorithm, so we have found out few important equations. So study what is the general formula of DFT. So x of k is equal to n is equal to 0 to n minus 1 x of n into wn whole to the power n into k. So that is a general formula of DFT. So based upon that, I have computed already. I already discussed in the previous slide. IDFT formula that is equal to 1 by n, k is equal to 0 to n minus 1 x of k into wn whole to the power minus nk. What is twiddle factor? Wn equal to e to the power minus j 2 pi n, twiddle factor. So these like a component you might have familiar in your laboratory experiment also. So next is called a DAT FFT butterfly equation. So we have two inputs, x1 equal to ABW, x2 is equal to A minus BW. So, so these are the major concepts. So DAT FFT equations. So you can say like x magnitude is equal to, or x cap is equal to A plus BW. Then x2 is equal to A minus BW. Number of computation, complex multiplication n by 2 log n base 2. So that is very important. Complex addition n log n base 2. So those concept also please do remember. State and prove circular time shift property. So if n x y of n is equal to x of n minus m into y, therefore y of k can be written as x of k w n whole to the power minus whole to the power like km. Proof very short. Substitute n replaces by n minus m. So we are modifying the equation like a sigma x a y of k is equal to sigma x of n minus m into wn whole to the power nk. Therefore, wn nk is equal to wn n minus m plus m k. So here m and m is getting cancelled. So only the particular term is retained. Okay. So the thing is you are able to get the final answer x of k into wn of mk. So that is the ultimate answer which you should follow up during your exam point. Kindly revise it once and go to the exam hall. State circular frequency shift property x y of n equal to uh, like x of n into wn whole to the power minus k. Okay, so from this expression, like you can easily calculate, then state the circular convolution. Okay, so those points you have to remember. State partial theorem, very short and proof. Exam ready is needed. I made a very short notes. I will share you once again. So next is explain the overlap add method. So please follow the statement. Okay, overlap add method. So overlaps the same method, add method. Split x of n into blocks of length L. Zero pad h of n to the length n because length should be matched. Calculation of DFT, multiply, then you will be able to get IDFT. Add blocks with overlap, find output y of n obtain. These are the few important steps for overlap add method. So another one is called Radix-2 FFT. Sorry, overlap same method. Okay, overlap input M1 samples, perform circular convolution, remove the N minus 1 and M minus 1 sample, then concentrate the remaining graph. So these are the suggestion from my side. So you can practice the similar kind of problems for you for the university examination. So read well and kindly note down important points accordingly. So happy learning. I wish you all the very best for your examination. Do well. Have a great day. Thank you all.